For this lesson, we're going to be continuing to look at word problems, and we're going to do 2 more examples. So our first question says that safety bylaws state that for a ladder to be stable, the angle of the base of the ladder makes with the ground should be between 70 degrees and 80 degrees. A safety inspector at a construction site notes that a painter is on a 10-meter ladder that is leaning against a wall, and that the base of the ladder is 1.5 meters away from the wall. Does the inspector have cause to be concerned? So when we get a word problem, the first thing we want to do is draw a diagram. So we have a ladder that's leaning against a wall. So here's my wall. And here is the floor. And it's safe to say that the wall makes a 90-degree angle with the floor. And we have a ladder leaning up against my wall like this. Now, some of the pieces of information we're given are that the ladder is 10 meters long, so we can label that. And we know that the ladder is 1.5 meters away from the wall at the base. And what the inspector needs to check is if the angle between the ladder and the floor is between 70 degrees and 80 degrees. So let's solve for that angle. So I'm going to start by circling the angle I'm looking for and labeling my triangle. So the side across from the right angle is my hypotenuse, and the side touching my angle is the adjacent side. So if we remember SOHCAHTOA, we have sine x is opposite over hypotenuse, cosine of x is adjacent over hypotenuse, and tan of x is opposite over adjacent. So because in example 1, I only have values for a and h, the only ratio I can use is cosine, because that's the only one that has an a and an h. So let's write out our equation. Cosine of our angle is equal to our adjacent side over our hypotenuse. And let's fill in our values. So the angle we're looking for is x. The length of our adjacent side is 1.5 meters, and the length of our hypotenuse is 10 meters. So now I'm going to take that fraction and divide it to turn it into a decimal. So we have 1.5 divided by 10, which is 0.15. So cosine of x is 0.15. And remember, that is not our angle value, that is the cosine of the angle. So we have to undo that cosine. So to do that, we do cosine inverse of 0.15. And if we type that into our calculator, we will get 81 degrees. Now, what we're looking for is we're trying to decide if the inspector should be concerned. So in order for this ladder to be safe, the angle between the ladder and the floor should be between 70 and 80. So since our angle is larger than 80, the ladder is not safe. So we can write our therefore statement. Therefore, the ladder is not safe because the angle is greater than 80 degrees. So that's our first example. Let's try another one. So in example 2, the highest point on a cliff is 80 meters above the lake shore. A surveyor stands on top of the cliff looking through a 1.5 meter tall transit instrument. He spots a boat on the lake at an angle of depression of 38 degrees. How far to the nearest tenth of a meter is it from the boat to the base of the cliff? So let's start by drawing a diagram. So first we have our cliff. So here's our cliff here. Something along these lines. And our cliff is 80 meters high. And on top of the cliff, we have a little instrument that is measuring distances. And we have somebody here measuring our distances. And this instrument is 1.5 meters tall. So in total, that side will be 81.5 meters. So I'm just going to label that whole side as 81.5 meters. Now our cliff is on a lake shore, so we have some water down here. And our cliff is looking at a boat. So our little guy up there is looking at this boat, and we know that he's looking at an angle of depression of 38 degrees. So remember that our angles of depression and our angles of elevation are measured from the horizontal. So we measure them from looking straight out like this and how far their chin moves down towards the boat. So we want to think about how far they move down towards our boat. Sorry, my line's not very straight, but I think you get the point. So this angle is 38 degrees. Now, in order to find the distance, we need the distance inside the triangle. So this whole thing here is a 90-degree angle. So we've used up 38 degrees of that 90. So to find the other, we're going to do 90 minus 38. So we're left with 52 degrees in here. Now it's also safe to say that the water makes a 90-degree angle with the cliff. So we do have a right angled triangle. And what we're looking for is the distance from the boat to the base of the cliff. So we're looking for this length here. So that's our situation. Sometimes people find it easier if you sketch the triangle separately once you have your diagram. So if you find this a lot easier to look at, that is absolutely okay. So let's go through and solve for our missing side. So we start by circling the angle we're given, and now we label our triangle. So the side touching the angle is my adjacent side, and the side across from my angle is my opposite side. So because we have opposite and adjacent, the only ratio we can use is our tan ratio. So tan of our angle is opposite over adjacent. So let's fill in our values. The angle we circled was 52, so that goes in for our angle. Our opposite side is the one we're looking for, or x, and the length of our adjacent side is 81.5 meters. So to get XL by itself, we need to get rid of this 81.5. It's currently being divided, so we need to multiply by 81.5 on this side and on this side. So we have 81.5 multiplied by tan 52, and that will be x. So now we just put that whole thing into our calculator, and you will get 104.3 meters. So now we can write our therefore statement. Therefore, the boat is 104.3 meters away from the base of the cliff. And that is our final answer.